Hey fitness guys, how are you doing today? Welcome to my channel. Have you ever wondered what exercise actually does for your brain? Yeah, I know exercise is not just about muscles, bones, it's about a whole lot more. What you don't see, it's in the inside, and it's so important to understand that when you train with me, I won't just train you for your muscles. I want to train you for your brain as well. Doesn't make sense, right? Tell you what, why don't you pop into my office and I'll explain the rest to you. Come on, let's go. Hey guys, welcome to another video. Now, I'm sure you're all aware of the several benefits that we have from working out, right? Mentally and physically, of course. However, there's one other that you might not have thought of, and that is the impact of exercise on our energy systems. Now, don't get scared if you never heard of that term. It's not very prominent. We don't always talk about it, but it is important. You can go look it up. There's several in our energy systems in our body, and I'll talk about 5 of them and the impact working out has on those energy systems. Let's start with number 1, the CNS, the central nervous system. Just like a computer has a CPU, central processing unit, our body has a CNS. Now, the brain is connected to the spinal cord, and from the spinal cord to the spinal cord are connected all the nerves through which the brain communicates its messages to the rest of the body. So what do you think happens when you're working out? Any guesses? Okay, well, the brain sends messages to those muscle groups to tell it what to do, to activate it, okay? The more you work out, the more neuron connections are made in the brain, okay? But not only that, but when we're working out, the heavier we lift, we're supplying more blood to the rest of we're pumping more blood, we're getting more blood going through the rest of the body. And not only that, we're breathing heavy, so we're getting fresh oxygenated blood into our brain. And of course, we all know what that does to the brain, right? Well, you put oxygen enriched blood in your brain, it's going to nourish it, it's going to keep it healthy. And if you keep your central nervous system healthy, what do you think will happen to the rest of the system? Of course, we all know the answer to that. So that's a very simple number 1 energy system in our body. All right, moving on to energy system 2. Remember these in no particular order. I'm just going through. I'm just numbering it as we're going through. So, number 2, the muscular system. Now, this is where the work is done and energy is produced. Okay, and what do you think we need to do to keep the integrity of our muscles? You guessed it, working out, right? Because we need stronger muscles. We need more blood flow going through our body. How do we do that? By exercising. Energy system number 2. System number 3, the skeletal system, okay, which is attached to the muscular system. Now, without the skeletal system, we'd not be able to stand, we'd not be able to move. Okay, so it's really important. By doing more workouts, by doing exercises, we're supplying, especially impact workout, we're making our bones stronger, supplying with more nutrients, which makes it stronger, especially as we get older. And for the ladies, we're more prone to get brittle bones as they get older. So it's really important that we have a good skeletal system, because without a skeletal system, we'll have no frame. And we'll not be able to have a good posture either. Okay, system number 3, guys. Energy system number 4, the cardiovascular system. This is made of the heart and the blood vessels. This is the fuel for the body. Okay, this is where all the nutrients, food is supplied to all the rest of the body. And when we're working out, the muscles are sending information to the central nervous system saying we need to open up more blood vessels so that we can get more blood going through the rest of the body. And of course, we know the end result of that, right? More blood that goes around the body, that is pumped around the body. We get more nutritious food being supplied to the rest of the body, more oxygen is supplied to the rest of the body, and of course, especially to the brain, which keeps our CNS, central nervous system, healthy. So we can't ignore that, can we? Moving on, guys. The 5th system, the endocrine system, almost commonly known as the hormonal system. You could almost say that this system is the repairing system of the body, so it can continue to do what it is designed to do. Hormones are the chemicals that the endocrine system releases. So it releases these chemicals so it can send messages to organs and tissues throughout the body. Once these chemicals are released, they go to their targeted areas. Some examples of these are adrenaline, which is released when the body is put under stress. So when you're working out, you get a high blood pressure. and you'll release you get high blood pressure and high metabolic rate. Another example would be estrogen, which helps to regulate your menstrual cycle, and insulin, which will reduce your blood glucose level. So these are just some examples of the hormones that get released in our body. Now, it is important that we have this in chemicals in balance in our body so we can function every day. What would you think of some of the impacts that we may have if we don't work out? What do you think will happen to these chemicals in our body? And what do you think will happen if we do work out in terms of having a fit, healthy life? Do you think these have an impact on how these chemicals are released in our body? One of the things that I might throw at you is that taking medication. Do you feel that will be another option for you? And can we continue to live a fit, healthy life and not take medication and have these hormones in balance? Right? Something gas to think about. Let's move on. Alright, so now that we've covered the 5 energy systems, I just briefly want to touch on the cardiovascular, or should I say cardiorespiratory system. This is the journey of an oxygen molecule that we breathe in. So we're breathing the oxygen molecule from our mouth, through our trachea, into our lungs, into our blood vessels, and the blood is pumped by our heart. It goes into our cells and muscles. And most importantly, this is where the oxygen is used to release the energy. So what do you think happens when we exercise? Do you think our heart rate goes up? Do you think the volume of oxygen that we breathe in is going to increase? And if we do increase the volume of oxygen, do you feel that it will make our body break the energy more effectively and increase immunity? Alright, let's have a look at our heart in not in great detail, but a little bit of detail so we understand how it functions, because it is an important part of our body, right? Okay, so if you didn't know, and I'm sure you already know this, but the heart is made up of 4 chambers. The top 2 are known as the right and left atrium. The bottom 2 is known as the right and left ventricles. So when we breathe out, all the carbon dioxide that is in the blood will enter the right atrium. From there, it'll go into the right ventricle, which is known as the pumping chamber. From here, it'll enter the lungs with all the carbon dioxide in there through the pulmonary arteries, and then from there, we'll breathe that carbon dioxide out. So what happens when we breathe in? When we breathe in, oxygen will come in through the pulmonary vein. Yes, of course, oxygen that we breathe in will come through the pulmonary veins, enter the heart in the left atrium. From there, it will enter into the left ventricle, and then from there, the oxygen-rich blood will go into the rest of the body through what we most commonly known as the arteries. Okay, so that's a little brief on how our heart works. So what do you think happens if we have a healthy heart? Do you think having a healthy heart means we'll have stronger immunity, we'll be able to fight germs, diseases? Do you believe that it'll give us a better eyesight, healthier skin, shiny nails, more hair? You know, these are questions I'm going to live with you and leave with you, and you can give it some thought. Now, there are also another importance of having blood flow in our body is when we're lifting weights, for example. So when we're lifting heavy weights, we need strength, right? That's how we become stronger, right? There's a way of measuring how heavy you can lift is one way of measuring your strength, I guess. There's several ways, but that's just one way. So what happens is when we're lifting something heavy, it's the brain sends a message to the motor nerve saying you need to get a greater contractual force, okay? And it does this by increasing the number of motor nerves and the muscle fiber inside our muscle belly, okay? The fibers inside our muscle belly. So it says, okay, well, you need more force. I'm going to supply more blood. We'll open up some more veins in there so you can get more blood supply, which will increase the motor nerves. And then when you have that, you will get more blood flow. The fibers will become bigger, and you'll be able to have a greater contractual force. You'll be able to lift more weights. Now, when you're able to do that, you get stronger. And this is known as muscle hydropathy. Basically what happens here is more proteins are being laid in the form of active myofilaments. What these do is they make the individual fibers much bigger. Okay, so when the muscles actually contract, this is known as depolarization, and when this happens, there's a release of a neurochemical called acetylcholine. Okay, now what acetylcholine does, it enters the what we call the cytoplasmic reticulum, what basically is a technical term for sex of calcium that is in the muscle fiber. So when it enters that, it heats it up. When it heats it up, the calcium is released, and then the calcium basically binds with the troponin. Following on from here, the myosin binds firmly with the active site of the actin filament. Okay, so when the actin filament now slides over the myosin filament, it is what we term as the power stroke. Okay, I know it's in great detail, but I thought I'd just share that with you. Kind of fascinating when you look at the molecular level. And then finally, the ATP molecule, which is at the end of the cross bridges, is released, and this is what is used to create the power stroke. So I hope you guys enjoyed this video, and I know it was quite detailed, and there were some technical terms in there. But, you know, it is good to understand how our body works, I believe, and always ask questions. You know, don't just assume information that is given to you, because science is evolving, and we must always be open to new ways of learning and educating ourselves. So I hope this was beneficial, and you know, I can't wait to share more videos with you guys. Till next time, take care.